Hi, we have the AP Physics 1 past paper 2016. We are discussing free response question section. Question 1 in this paper. A wooden wheel of the mass m consisting of a rim with spokes rolled down a ramp with making an angle theta with horizontal as shown in a fig. The ramp exerts a force of static friction on the wheel so that wheel roll without slipping. So first part of the question is on the diagram below, draw and label the forces, not components, act on a wheel as it rolls down the ramp, which is indicated by the dashed line as shown in a fig to clarity indicate at which point on a wheel force exerts. Draw each force as a distinct arrow starting and pointing away from the point at which the force is exerted. The length of arrow and no need not to indicate relative magnitude of the forces. Mean the length of the vector is not according to the force magnitude but only indication. So normal is acting from the point of contact where the dash line it is represented in a green line. Static friction is opposing force, so it is directed toward upward of the dash line and the weight is always acted at the center. So red line is indicating the weight. So these are the three forces that is acting on a wheel: normal force, weight and the static friction. Second part of the question, as the wheel rolled down the ramp, which force causes the change in angular velocity of the wheel with respect to center of mass? Okay, I have indicated the static friction is the force that causing the angular frequency to change. Static friction is the only force that exerts the torque about the center of mass. Torque is equal to R cross F. Here is the force of friction I indicate because torque causes angular acceleration. Tau is equal to I alpha. Alpha is equal to rate of change of angular velocity. Mean indicated the change in velocity. Friction change over the time. Without friction, the wheel would slide down without rotating and omega would be 0. And now why not the other forces? Because question is about the center of mass. So normal force is also passing through the center of mass. The moment arm in this case should be 0. Weight is also acting at the center of mass. So moment arm is equal to 0 in this case. So only force that is acting along have the moment arm is the static friction. That is causes the angular acceleration or change of velocity. So that's the reason we have indicate the static friction is the only force that cause the change in angular velocity. Next part of the question, for this ramp angle, the force of friction exerted on a wheel is less than the maximal possible static friction. Instead, magnitude of force of static friction is 40% of the magnitude of the force or force of the component directed opposite to the force of friction. Drives the expression for linear acceleration of the wheel center of mass in terms of m, theta, and physical constant. Okay, given is that force of friction is 40% of the that force that is opposite to the frictional force. So I have write 0.4 and multiple component of the force. I have indicated the component of force is mg sine theta that is opposite to the static friction. From this figure you can see weight has the two component. Mg sine theta is the component that is acting in opposite direction. So we say that that's the component mg sine theta, the component directed opposite to the friction. F, we come to know value of force of friction. Now net force acting mg sine theta minus F. So F force of friction we have value 0.4 mg sine theta. Mg sine theta can be taken common. We have the 0.6 g sine of theta. M should be cancelled because we have to come to know the linear acceleration. So linear acceleration is equal to 0.6 g sine of theta. That's the answer. In next part, in second experiment, the same ramp, a block of ice, now the block, not the wheel, with the mass m is released from rest same instant as the wheel released from the rest at the same height. The block slide ramp with the negligible friction. Question is which objective either reach the bottom at the ramp, greater speed, wheel, block, neither. I mean both will be same speed. So we have to see rolling wheel versus sliding block. Now block will reach the bottom with the greater speed. I have given the answer. Now reason. Net block on the force is mg sine theta and m should be cancelled. A is equal to g sine theta. That is case of block. But in case of wheel, we have to know the wheel have the acceleration 0.6 g sine of theta in part B. So from equation 1 and 2, we can see the block has the acceleration greater than the wheel. So g sine theta is greater than 0.6 g sine of theta. Block almost no opposing force, negligible friction. The full gravity component accelerated. Wheel has significant friction opposing to translate and to enable the rotation, reducing the net force on a wheel. So that's the reason the block will slide with greater speed. Okay. Next part, explain your answer again. Now reasoning in term of energy. Okay, block slide translate without friction. All converted potential energy because it is at the height will go to the translational kinetic energy. But wheel not only translate but also rotate. Potential energy must be split into two forms of kinetic energy, translational kinetic energy, rotational kinetic energy. So less translational kinetic energy compared to block, smaller translational kinetic energy means smaller final speed. So therefore block has the greater final speed at the end. That's the answer. If you have any query, kindly ask in a comment. Okay. Take care.